Okay, we are live. Hello, everyone. We are ControlByte. My name is Matthew Kurantovich, and with me is Jacob Bydulski. Together,
Hi.
we run a company, and we have a YouTube channel with automation and robotics videos. Welcome, everyone, on a chat. Firstly, subscribe our channel and hit the like button to stay tuned with our videos. And let's get started. In this live stream, we will look at edge detection functions in PLC programming. We'll talk about what is it, why it is important, and how to use it in PLC projects. You will see different examples and how to solve common problems using those instructions. Here's the plan of our live stream. Firstly, we will describe how to use edge detection functions in ladder language. We use TIA Portal from Siemens. This is an environment for PLC programming, especially in ladder and text languages. Next, we will go to the topic how to wire buttons and sensors to physical PLC hardware. And for automation engineers, it is important not only how to program, but also how to wire the entire system, PLC, buttons, sensors, and etc. Next, we'll go to TIA portal and we will describe how edge detection functions works in practice. So you need to know something about two instructions: positive edge detection, P trig, and negative edge detection, F trig. It is important to write your own signal edge detection function to understand how PLC cycle works. And it is one of the basic program which you need to know, because sometimes during the interview for a job, you need to write such a program. We will look at common errors using triggers. We have some examples, and we will see how to remove fluctuations from our signal. We will analyze the PLC program with triggers, and stay with us to the end of our live stream because we have a prize for you. We have a competition and you can win something from our company, ControlByte. Okay, let's go next. My name is Matthew. With me is Jacob. We have started our company a few years ago. We have started our company since 2019, and we have some questions to you. Write on the chat, where do you come from and what do you want to learn from us? Remember about subscribing and hit the like button. Where do you come from and what do you want to learn?
You can write on the chat or in the comment down below this video.
Yeah. Okay, so who we are, what we do. We deal with machine and automation system design, and we have started an online platform for automation engineers. We teach how to program PLCs and how to design automation systems. We specialize in a variety of areas, including PLC and robot programming, control system design, machine safety system, data acquisition system, and machine design and constructions. Our expertise is programming PLC and robots. We know a lot about automation and robotics, and that's why we can help you to learn these things online. What we do for our customers, we supply robotic stations for palletizing and depalletizing in the wood processing industry. If you are sitting on an IKEA chair, it's quite likely that our robot had a hand in making it. We are proud to be a part of creating everyday items that people use and enjoy. And we are the part of fourth industrial revolution. We integrate automation system in factories. We collaborate with manufacturers such Lensa, Tark, Wieland Electric, and many more. We use hardware from these companies. For example, Lensa is a manufacturer of servo drives. Tark have sensors and different devices, and Wieland is a company which have system safety devices. You can find us on LinkedIn. My name is Matthew Kurantovich. You can type on LinkedIn, and we can get in touch. We share a lot of content about automation and robotics on LinkedIn. You can find more about that. What can you learn with ControlByte? We have a lot of programming courses. Now we translated programming courses for TIA Portal in Siemens for S7 1200 and S7 1500 for ladder language and STL language. What's more, we teach how to program in Codices programming environment. It is a modern environment for professionals. You can design and program inside of this environment industrial applications and building automations. What's more, we teach fundamentals of automation design, drawings, electrical schematics, and we teach motion control programming. How does it look like on our platform? We have online course on e-learning platform, a lot of video materials with some task for you. This is you and your computer. You don't need expensive hardware. You learn only using free simulators like PLC Sim from Siemens, and for example, trial version for Factory IO environment, which is a software which simulates the factory in 3D. What's more, we have live meetings and well-developed Discord channel. We support our subscribers, our students on Discords, and this is the place where you can easily get a support from us. Okay, let's start with our topic of our live stream, and let's describe digital signals in automation systems. Okay, Jacob, so you can describe what we have here on the slide. We have hardware, normally open and normally closed contacts, and sensor.
Yes. In automation system, you have digital and analog signals overall. So digital signals have two states: true or false, zero or one. But sometimes you can find normally open or normally closed contacts. How does it work? Normally open contacts are used to start some machine functionalities, and normally closed contacts usually are used to stop those functionalities. For example, in our system, we have a simple conveyor, start button and stop button. In the system, we use start button to start the entire line and stop button to stop the line. Usually, we use normally open contacts for start button, as you can see in this tag list. When the button is not pushed, not pressed, the state of the signal is false. When I press the button, this little lamp LED is highlighted. Normally closed contacts are used to stop the working state of the machine. Why is it? Because in automation systems, some malfunctions of wiring may occur, for example, and our button or our sensor can be cut off from the system. And if the button will be cut off from the system, the circuit will be opened so that it will be impossible to start the machine because the signal state in the PLC will be 0, will be false. So generally, there are normally open contacts, normally closed contacts, and in most cases, we use only steady signals for those sensors, for those equipment, like true or false. But sometimes we need to detect the transition from the false to true or from true to false state. Matthew, can you move to the other slide?
Okay, but firstly, we have our subscribers on the chat. So here we have 0xFF from Nepal. Nice to see you here. And you want to learn PLC for industrial automation, to develop SCADA system for water treatment and sewage plants, computer industrial sensors and actuators. So with our courses and our free materials on YouTube, you will gain a lot of knowledge about PLC systems. So stay with us, and we encourage you to buy our course. We have 2 courses right now. One is entry with really small price. You can join our Discord channel and our platform. And another, we have a premium course for more sophisticated projects. And here we have a question. MDB asked a question: what is the difference from cost €10 to and €90? I receive emails on different prices. Now, the price is going higher because we recorded a lot of videos in our projects, but the more expensive price is for premium course, and you will find there a lot of sophisticated projects, and that's why prices differ. Okay.
For €10, $10, you can get the course with about 6 hours of video lessons, video materials, and basic projects. There are about 5 to 6 projects, basic projects. And in premium course, you will get the whole ladder training program. There are over 24 hours of video lessons and many more projects, about 15 projects overall.
Yeah, so in the premium course, you will get access to more sophisticated projects, like project with building sequences, graph set, more sophisticated machines. Okay, and in entry course, you will get access only for just simple projects. Okay, uh, and
The
this
basic course covers Boolean operations and projects related to basic projects with Boolean BitLogic operations. In the full course, you will write your own PID regulator, for example, and many more. We introduce their operations on integer, on floating point numbers. You will get to know how to write sequence in ladder logic, how to build the entire application, how to use structures, and many more. So
okay, so we will explain it in the end of the video. You will see the difference between the courses,
yeah,
and we encourage you to buy our premium course. Okay, but let's go further with our presentation.
yeah. During those YouTube meetings, we cover basic topics, like, for example, like today's triggers. In our course, those materials will be extended. It will be covered with
Yeah,
presentation
yeah. Yeah,
online.
on YouTube,
Online.
we have only the basic concepts, like here the presentation. That's all. But inside the course, inside our platform, you will get access to template projects, ready made projects in TA portal, and many more materials for learning. Okay, let's go further. What do you need? Why do you need triggers, Jacob? Why do you need triggers in projects? Maybe you can write on the chat, why do you need triggers in PLC programming? Why do you need triggers? We have a lot of points for that. For example, we use triggers for start and stop functions for our machine. In our courses, you will find the descriptions how to design a network in ladder logic for start stop machine. This is the basic network which every machine should have, and we need to use their trigger to mm, to detect signal edge detection. Okay, next we have sequencing operations for machine also.
If you program sequential system for machines, for processes, trigger instructions can be used to initiate the next step or the next process in the sequence. So the transitions in the sequence are made usually by triggers. But you use triggers instructions to detect the exact moment to transfer the machine state from one state to another.
So sequencing operations are commonly used in manufacturing systems where certain processes must follow a strict sequence. Okay, so next, detecting start and the end of material in conveying system.
I will show you this functionality in a moment with the factory I/O scene.
Okay. So next, condition monitoring. In applications where certain condition must be maintained, like temperature, pressure, a trigger can be used to initiate corrective actions when these conditions go out of their specified range. Okay.
Yeah, the fourth and the fifth point are connected. Triggers are used to um, in alarming systems. For example, if you have a temperature signal from the sensor, you can detect the over temperature alarm by using the trigger connected to the comparator instruction. And the last point is the event counting. In all the counters, you have to use triggers to increment the counter in the function block. So as you can see on those two pictures, maybe we'll start with the right. Usually, you can use a steady signal, false or true, for Boolean variables, like in our system.
So
But
here we have marked on red the false signal, and here marked in blue we have ready state signal like true. Okay.
yeah, but sometimes you have to detect the transition moment, the exact moment of transition between those two states, between the false state and the true state of the signal. And this state should be alarmed or should be detected only for one PLC cycle. As you can see on the diagram on the left, we have like little needles on the upper diagram, and those are triggers, positive triggers of the signal from the below diagram.
So maybe in the future, in our future live stream, we will describe how the PLC cycle works. Okay, because if you want to understand how the triggers works, you need to understand how the PLC cycle works. But here you have like only one cycle of PLC, and here you can see on the graph how it works.
Okay, let's move on to the next slide. So now let's analyze standard basic library in TIA portal. Let's see which instructions can we use to detect signals edge. In this picture, you can see three different trigger instructions that you can detect the edge with those instructions. So you have a contact with a letter P on the first rank or on the first branch. This is the basic positive trigger instruction for detecting the rising edge with connected operand, with the connected variable above this instruction.
Yeah, for example, it could be a push button mounted on the control cabinet, for example, start button. And here we have the address of this button, and below this symbol P, we have a memory bit for that.
Yeah.
So this is the first symbol for detecting positive edge detection. So transition from false to true. Okay.
The next instructions is R trig. R trig is the trigger instructions that involves data block to store the data, store the memory that we can use in other program in our other networks in the program. I will show you this in a moment. And the last instruction is p-trig. This is also used to detect the rising edge, but here we, on the CLK input, we detect the result of logic operations from the left of this instruction, from the left.
Yeah, so something like last logic operations, and here we can connect more sophisticated logic and connect the result of this logic to the CLK input of p-trig instruction, and look at the difference between p-trig and r-trig. We have a difference in inputs, number of inputs. For r-trig, we have also an enable input. So enable input is for enabling this instruction. If we pass here, if we connect here, for example, true state, the function works properly. If we connect here the false state, the r-trig function is disabled. It doesn't work in our program.
Yeah, we'll show you this in a moment. Now you should remember that there are three types of rising edge detection instructions in TIA portal. And we'll start with the basic instructions. We'll show you how it works with the live example. So let's move on to TIA portal. As you may remember from the previous slide, triggers are used to detect start and end of material or products in the production line. For example, here you can see some packages, and if I start the conveyor, okay, roller conveyor, sorry. The package will be moved just next to the diffuse sensor. In front of the sensor, the package initiates the sensor signals and it goes to high states. You can use the signal right here. So, how to detect the start of this package, the beginning of the packages in the line? I can write a simple program. Here I have the starting system for the conveyor. I will start the system with start button, and I can stop the conveyor with this sensor's signal. So, if I want to detect the beginning of the package, I have to use rising trigger. This sensor is normally open. So now this sensor's signal is false. Here you can see normally open contact. I have to click twice on this contact and select positive trigger for this instruction. Down below this instruction, you can see some red field right here. You have to assign memory bit for this trigger instruction. Okay. Now I will download this program to the PLC. I'm working on the simulator, and if you configure the entire system as I did, you can also perform this exercise on your computer. You don't need a real PLC. Okay, now I press start button. And as soon as the package reached the sensor, it stopped. With the positive trigger, I detected the beginning of the package. And now how to detect the package end? I have to use negative trigger. Okay. Now I will detect the transition between true state and false state of this sensor. Have you seen the difference? In the first configuration, the package stopped just after reaching the sensor, and now the package was moved just right here. Now the sensor signal is false. So this is the difference. This is the functionality to detect the beginning of the material and the ending of the material with positive and negative sensor. Positive and negative triggers, of course.
It's really simple. Just double click on the instruction and you can change the functionality of your program.
Yeah, we can also, for example, check this signal on a trace. Okay. And on the blue trace, you can see the X motor. Why is the button? Okay.
Oh, X motor button.
X motor variable. And here you can see rising edge of the sensor's signal, but the motor is still running. And after detecting the falling edge, the motor is immediately stopped. So with this negative trigger instruction, you can detect the end of the package. Okay, the next functionality that you have to use triggers with is counting packages. Okay. I will change the program. Okay. Here you can see counter CTU counter that counts up to 4 packages, and it counts the signal from this sensor. So after starting the system, okay, I have to reset the program, and okay, and let's start. So now this counter is counting to 4 packages, 2 packages, 3 packages, and 4 packages. But take a closer look. Now the sensor sees the package, but it sees the front of the package, and the counter counted to 4 packages when this sensor saw the front of the package. If you want to move the package behind the sensor into this zone, you have to also use trigger. For example, and trick right here. Okay. But now I have to reset the simulation in a moment. Okay, now it's okay. First package, the second package, the third package, and the fourth. And okay, I have to move the bumper a little farther. Okay. First package, second package, and third and fourth. And after the fourth, the system stopped. In previous example, the system stopped with the package in front of the sensor. Now it stopped after the package was moved to the right. So this is the difference when we use triggers in combination with counter and when we don't use triggers. Okay, let's move on to another example. We mentioned an example starting stopping system for industrial line or industrial systems. Here you can see a flip-flop, X state start. You initiate the state start with start button and you stop the line with stop button. Okay, but what can happen if in our system a malfunction or failure occurs? For example, if our start button will stuck, what will happen? Let's see right now. We can simulate a failure in factory I/O by simply clicking this icon next to the start button tag. Now the start button is short circuit. It means that it is switched on constantly. As you can see, the start button is highlighted in green right here, and our system is switched on all the time. The roller conveyor is on, even if the system has counted to 4 and should have stopped the machine. The machine is still running. how can we prevent such a situation? We can insert here trigger instruction for the start button. It is a common practice in automation systems. Okay. Okay, let's reset the simulation. And now let's cause a failure in our system. Okay, the start button is short circuit to high state. And let's see if our system will work. Okay, the start button is short circuit to high state all the time, but here we have a trigger in setting input of this flip-flop. So now our system stopped after counting to 3. As you can see, we have declared here 4 packages, and sometimes if the PLC is in stop state and it is transferred into run mode again, after the first PLC cycle, the CTU counter counts 1 package. This is because the first cycle we can solve this problem by using, for example, initial call instruction. But this is the topic for another meeting. Now let's analyze the triggers that we can use in TIA portal. Okay, so to sum up this exercise, this presentation of the trigger, we can use the trigger to prevent the failure state of our starting devices, like start push buttons, like some levers, pedals, and so on. So if you have a mechanical contact that can stack and can start our system unintentionally, you can insert positive trigger signal detection instruction to prevent this malfunction. Okay, let's move on to describe different triggers that you can find in BitLogic operations library. We have used ptrig. This instruction scans operand for positive signals edge. So as you can see, we have to assign a variable, a signal that this instruction will inspect to detect the rising trigger. Matthew, maybe we can move on to our presentation. You have... Okay, wait a moment.
Yeah. We have here signal edge detection, and here we have the rising edge of the assigned operand. And look at that. Here we have a simple symbol, contact symbol with letter P, marked with letter P, and we detect the rising edge of the signal thanks to that. Here we can put an input, for example, for button or on sensor, and down below the symbol we have a memory bit for that. What's more, we have the diagram here, and we can see that for one cycle only, we can detect the transition from the low state to the high state of the physical input of our PLC.
What is important about this instruction in comparison with the other trigger instructions is that this instruction only detects the trigger on a sole signal. So if you have, for example, X start variable, it detects the rising edge on this signal. The other instruction can be used to detect a trigger of a code or combination of other instructions. So here you can use this instruction to detect the trigger on the assigned operand, and the other instructions can be used to detect the result of other operations.
And what you need to remember is that you take a transition from false state to true state, and the contact for this instruction, this contact, P contact, is closed for only one program cycle when the transition occurs. Okay, and that's all. Thanks to that, you can design the logic of your program.
Yeah, you can count events and many more.
Yes.
Okay,
What's
let's
more,
move on.
we have one important slide here, and you can easily write your own program trigger function. What I would like to say that this program is usually the common program when you can find in a job interview. And when you apply for a job, you go for interview. The interviewer asks you questions, and one of the example that you need to write is trigger function. Why? Because if you write this example on your own,
Okay, I will show you how to write this simple program right here. For example, you can use start button signal, and you have to declare X
okay, but if you write this program on your own, the interviewer knows that you know how the PLC cycle works.
Yeah.
And this is very important to understand that, especially when you apply for a job. So you can watch this example in a very and focus on that, because you will find this example on your interview, on your job interview.
Okay. And the most important branch will be to transfer the state of the start button from the current PLC cycle to the next cycle at the end of the program. So, as you may remember, I have told that the trigger instruction detects the transition between states. For example, if our start button is in false state and okay, we have to change this right here like this. Okay. If our start button in previous state was in false state and now it is in high state, it will be positive trigger. And if the start button in previous state was in high state and now it is in low state, this is negative trigger. The trick for this is to transfer the signal state between the PLC cycles. As you may remember, the PLC works in cycles. Every cycle takes about a few milliseconds. And at the end of the code, we transfer the state of the start button to the auxiliary variable x previous state. And in the next PLC cycle, we start our code with checking the state of the current state of the start button and the state from the previous PLC cycle. And if the previous state from the previous PLC cycle is different from the state from the current cycle, the trigger is detected. The positive or negative trigger, it depends on the transition that has occurred. Okay, let's move on with the presentation. Okay, negative edge detections instruction. We have covered this topic, so let's move on.
Yeah, this is the same as positive edge detection, but this is for negative edge detection. Okay, so we detect transition from the high state to the low state. And here we have different instructions like rising edge, RLO scan. What is RLO? Is detection
result of last operation.
Last logic operation. Yeah, of course. And what we have here, you can see the difference between previous instructions. We have here the name of instruction is different. So we have P-trick, and we have one input CLK and one output Q. Below the symbol of this instruction, we have a memory bit which stores the value of our edge. What we can do here, we can create a simple program and see and show the differences. But we can comment here the result of logic operations. We don't detect the signal from only one variable. We detect signals from the logic operation.
Yeah, let's assume that you have some logic right here. For example, we have output from the counter, and if you put here standard contact with P, it will be impossible to insert here a variable, or you can, for example, insert here variable from this data block, but it is not, it doesn't look nice. So to use this branch with and use this Q output from the CTU, you can use ptrick instruction, and you can connect Q output of the CTU with the CLK input of the ptrick. Of course, you have to declare some memory bit here. It's important, you have to declare this memory bit in M memory or in data block in memory that will not be erased between PLC cycles. If you would declare this variable in temporary variables, this trigger won't work. Okay, and here you have to assign output after this ptrick. As you can see, with this little arrow, you won't compile your program. There will be error, so you have to assign an output to ptrick instruction. Okay, let's move on with the presentation. Matthew, you have muted the microphone.
And we have here a common error using triggers, for example, ptrick for positive edge detection. And look at that, we have two conveyors. Here we have the first conveyor, and on the another address we have second conveyor, but we use the same instruction for both conveyors. Same signal edge instructions, positive edge instructions for both conveyors, and this is the error. Why this is the error?
As you may remember from the previous slide, the auxiliary memory bit stores the value of the operand from the previous PLC cycle. So on the first branch, after executing the instruction, the state of the X push button start after executing the instruction will be transferred to X mem0. And then on the second branch, the X push button start will be compared with the state of X mem0, and it was overwritten in the first network. So the second in the first branch. So the second branch, the second rank, won't work. It won't detect the rising edge, the positive edge of this signal.
Yes,
If you,
and you need to know that the modern environments have debuggers inside, and we can debug our program and search for errors like that. And this debugger is really helpful for beginners to understand how instructions works in a program. And
this is common error
yeah.
that our students commit in their homework, because they copy and paste, for example, positive trigger for start button several times in the code, and they say, oh, my piece of code regarding, for example, the second conveyor or something doesn't work, why the triggers don't work. So that's why you cannot use the auxiliary bit for the triggers in several places in your code, how to solve this problem. If you want to use your trigger more than once in the code, you have to use our trick. As you can see, I have placed this instruction in my code and a little pop-up appeared. Now I have to declare the instance of data block connected to this instruction. Here you can see db2. This is the instance of data block connected to this trigger. Here I can connect, for example, start button. And now I can relate to this trigger. I can, for example, change the name of this. Wait. Fast. I can rename this. Why I can't rename this data block? Wait a moment.
So for you, it's really important, especially for beginners, how to debug
I'm
your program.
online. I have to be offline.
You can
And I
debug in
can
different ways.
trick start. Okay. Okay. Okay, now I have trick start db, and I can relate to this trigger instructions by selecting Q output of this function block. Here you can see this data block instance. We have here CLK input, Q output, and static bit. So now in my program, I can relate to trigger of start button in the whole PLC program without problems. So this is the answer to the problem that we have showed on the slide. Okay, let's move on to another problem, another error connected to triggers in TIA portal. Signals debouncing. This phenomenon can occur in systems where you have mechanical contacts. For example, relays, switches, limit switches, buttons, and many more. The mechanical contacts where they are switched on may momentarily bounce together and apart before settling into a stable state. Here on the presentation, you can see multiple transitions between the high state and low state of the signal. The high state is about 24 volts, and after the signal is settled, it fluctuates a few times up and down. And for example, if you have a trigger that counts the events in the code, that is responsible for example, for counting the events, it can detect more than one event occurrence in this system. So how can you solve this problem? How can you count the transition only once without counting this debouncing states? you can program a special delay timer in your code, or you can configure hardware for your input channel to filter these fluctuations. For example, here I have Siemens PLC 1200 CPU. I will go to digital inputs. Here you can configure your input channels for your PLC. And for example, for the channel 0, you can select proper input filter so that you can filter the signals fluctuations, as you could see on the oscilloscope trace.
Yeah, of course. In PLC,
usually,
programming is also really important to configure the hardware, not only programming. So stay tuned with our YouTube videos because we will show more about hardware,
yeah.
not only about PLCs, but peripherals like
You can select
devices.
input filter from, for example, 0.1 microseconds. So this is no filtering at all, to 20 milliseconds. Transitions and debouncing in mechanical contacts are about 1 to 2 milliseconds. So if you observe such a malfunction, you can, for example, select 6.4 or 10 milliseconds for the inputs, so it will be a safe value and no error will occur in your system. Okay, let's move on to the presentation.
Yeah, here we have the filter. Okay, and let's go. Okay, this is the end of our practical part of our live stream. And now let's go to our last part. How to boost your programming skills. Okay, so what you need to do is to join our Discord channel. You can share your projects with others, for example, on our Discord or LinkedIn. And you can give us your programs for review. On our courses, we review your projects on Discord and we will give you a feedback. This is the best way to learn to code. What's more, you can learn from others, from professionals like us, from ControlByte company, and this is the quickest option to learn how to program PLCs. What's more, you can help others. If you gain some knowledge, you can help others on our Discord, and you can next sign up for our premium PLC course. What do you get after enrolling our course? Over 46 practical videos lessons, more than 6 hours. This is our entry level course for everyone. We support you on our Discord chats. We have live meetings. You can use your microphones on the Discord, and we can talk about programming PLCs. We have prepared a lot of homework assignments for you to complete on your own, and we will give you a feedback. We'll review your code. What's more, you have a certificate of course completion. You need to give us your homeworks, and we will give you a certificate. And you have access to professionals from automation branch. You can get a job in the future. We have a lot of contacts, and we can give you a job offer. You can apply and start your career in automation and robotics. How to get a job in automation? You need to set a goal. Then you have a plan and an action. An action is, for example, create and send CV, build a portfolio with us, and gain skills, for example, PLC programming. You need the ladder language. This is the best language for beginners, and every big company uses this language. And you will work with that language. Think about that. Are you ready for seeking a job? Are you ready to start new projects in automation? If not, just enroll in our course, sign up for our course, and you will quickly see results of your learning path. So with us, you will create a portfolio. Which projects? For example, here we have buffering containers projects. You will use CTUD counters. You will learn about bit instructions, for example, normally open contacts, normally close, calls, Boolean algebra, and we'll explain everything from scratch. If you don't know about PLC, we explain from scratch on our e-learning platform. Next, we have flip-flops, and if you learn basic instructions from standard library, you will easily go to the projects. For example, projects with roller conveyors, you will use here only basic logic based on normally open, normally closed contacts, flip-flops. And next we have triggers. In today's live stream, we explained how to use triggers in different situations, programming situations. You will use P trick, R trick, and more instructions in your projects. And thanks to that, you can create more sophisticated automation process like sorting with pneumatic actuator. You will use whole knowledge that you gained. Next, we have timers. We will cover timers in next live stream, which will be on our channel next week. And here we have project programming alarm timer for conveyor. Next, we have counters and project buffering containers. The last final project will be pallet sorting line based on product height. Okay, so MDB, our subscriber, said that he signed up for our courses. He learned a lot, and now he's waiting for more. For example, like servo drives programming.
Yeah, we're working on the servo drives course. We have all the materials, but we have to proceed with the materials creating process in English. So we have those materials in different languages, and now we are translating those materials into English. Our servo drives course was accomplished over by 200 students so far. So it is really nice course. Now we have the basic PLC courses. Matthew, maybe you can show our website.
Yeah, here we have entry-level PLC programming course for Siemens S7 1200 PLC, and you will this course covers ladder logic basics. Here we have a video, and Jacob will explain you what you will realize in this course. And next we have the plan of projects that you will realize. Here you can preview lessons, for example, how to create the first project, how to add HMI panel to your project. If you click here, you will find sample materials, video materials. What is inside the course. And here everything you can the whole course you can buy in a price $12 right now.
Yeah, this is the entry course that everyone can afford. You can check if PLC programming is for you, and if you perform the basic projects, if you finish your assignments, you can start the full PLC training as our student MDB.
How much a PLC programmer can earn monthly?
We
For
have
example, on a contract, you can earn a lot of money, but on the contract, you can, for example, earn 10,000 euros or more
yeah.
per month before tax.
If you are qualified PLC programmer, you have some experience. It is about 50-60 dollars per hour. In our presentation, we had a slide with typical salary in England, in Great Britain, and the typical salary for a full-time PLC programmer is about 50 to 60,000 pounds a year.
Yeah, of course, in Great Britain, but yesterday my colleague said that he will go for a contract to Saudi Arabia, and they will start up a machine, an industrial machine, and I think the salary will be the same as in Europe, or even you can earn even more. So
Yeah.
it depends on your skills and depends on the project, location, contract, and many more. Yes. What's more, you can pay for the course by PayPal or Stripe. If you want to pay for a course in a different way, by a different gateway, just write us on email, contact at ControlByte.tech. Here we have positive opinions from our students from Central Europe and Western Europe.
Yeah.
Here we have frequently asked questions, and here you have the price of the course. If you click here, enroll in this course, you will go to the checkout page and you can pay by PayPal or by credit card.
MDB writes in Germany, works for one industry 45 to 80,000 euros per year. Yeah, this is true.
Okay, and MDB, are you from Europe? Because I saw our survey and a lot of people are from Asia right today, 83%, and from Europe is only 16%. Maybe because of the morning time. The Europe works at this time, I think. That's why
You can
they are
write
not
on
with
the
us.
chat what time would you like to meet us on YouTube. So in
It's
the
clear for
morning,
me.
in the afternoon,
For
or
Asia in the morning and for Europe
yeah.
the evening. Okay. Okay, but this is the entry course, and we have another course, the premium one. But in our opinion, the best way is to enroll in this one, and we will contact with you, and you will get access to you will get to know how to get access to our premium course. Germany, very nice. It's really close to us. I studied in Germany, and I worked in Germany. So all the best. See you next time. See you on our platform. Very nice. Okay, so the last part will be the competition for you, and we'll go to the end of our live stream. Okay, so maybe I will write a competition right now. I can't hear you, Jacob.
The rules for this little game. If you know the answer for the question, you have to write the correct answer to contact at controlbyte.tech. So for our to our email box, write the correct answer to contact controlbyte.tech. And Matthew will show the question on the screen in a moment.
The question is simple, and it refers to our live stream, I suppose.
You can win a discount for our course. So if you send a correct answer to our email address, we'll send you a discount for the course. The price for the entry course is really low, and you can save another a few dollars if you know the correct answer.
Okay, so here we have a question.
No, this is not the question.
Please write in the in the chat.
This is not the question.
Please write on email. Wait a minute. Please write. Okay. Please wait a minute. Please write.
Our viewer is asking, is it possible to get a job in Europe by learning PLC from a South Asia country? What are the requirements? It is possible because many companies hire programmers for a contract. For example, if you get into a contract, you will go, for example, for half a year or a whole year somewhere where they are building a new factory, and they have to establish a new production line. Those projects require you to be on this place for, as I said, half a month, half a year, or entire year. And for those companies, it is really hard to find a person who want to be abroad on working the entire year outside his country. So it is high demand.
If you are ready to relocate, from Asia to Europe for a project which lasts, for example, 1 year, you will have a really big chance to get this job.
Yeah, you have to know the basics of PLC programming, it is often it is that the company that will hire you will send you for a training covered by this company's, for example, professionals or trainers. So if it is a big company, they will send you to the proper training facility, or they will deliver the training themselves.
Okay,
But
so here
you
we
have to
have
know the basics of PLC programming to
okay,
for the
here
interview.
we have the question, because we are going to end. Please write how to detect transition from high state to low state in PLC programming. Write the name of the function to our email address, contact at controlbyte.tech. So it refers to our webinar. Please write how to detect transition from high state to low state. Write the name of the function. Okay, so we have the high state, we have transition to low state, and we would like to detect this in our program. So this is a trigger, but we
There
need
are
to
many
know
kinds
a
of
name of
triggers.
that.
Yeah, there are 6 types of triggers, so you have to choose the right one and write the name of the trigger in the email
Okay, so
to our mailbox.
we are going to end this live stream in a second. So thank you for participation in our live stream. Thank you for subscribe, hit the like button, and bell and notification ring to stay tuned with our automation and robotics video materials, and see you later next week.
Thank you, and see you in the next week.
Remember about the question.
Yeah.